Hello everyone, and thank you for being here, so to speak. My name is Andi, and it's a great honor to be speaking at B-Sides this year. I would like to thank the organizers for their amazing work, and I hope everyone is staying safe and sound during these hard times we are facing. Now, a little bit about myself. My name is Andi Anastasi. I am a threat labs engineer at Encode. As we like to say, we like to pentest all things, the code, but what I especially love is web and iOS penetration testing. The things I'm about to present today, of course, are not my work solely. We have a great team at Encode, and the two colleagues that work with me in this is Manus and Alex. So what I'm about to present today is, as we said, a tale from our crypt. We are about to present something similar to what we saw. So it's not the same application, but we have mimicked a behavior into a demo iOS application. We have changed a lot of things, of course, in order to, for confidentiality reasons. But the meaning of the story and the process we are about to follow is the same and should work if you face something similar. So, you start on a mobile application penetration test. You have set up your device, you have configured your proxy settings, you have trusted the certificates, and now you're ready to see the traffic in your proxy. Sometimes you're lucky. This is something that might seem scary or funny to you, but it's something that we have actually seen in the past during one of our projects. This is not the case, however, otherwise this would be a short presentation. Sometimes you're simply okay, you see what you expect to see, and you move on with the testing, and sometimes maybe it's not your day. So, when you see this, you get scary, and we start the questions. Starting with the what. What are these parameters we saw? And fortunately, we have friends that can assist us. We'll be showing how you can see what the application is doing and how you can interfere with it by using Hopper disassembler and frida. Of course, you can use any other disassembler you like, but I prefer this one, and this is how the example is gonna go from now. So, time for a short demo. So, we have our device ready, and we just need to install the application and fire it up. Once we start the application, we normally see the traffic that's generated by the app. In this case, we see that the first request, it's this interesting string, and after logging and clicking on one order, we see the traffic that we saw earlier. This is quite interesting since it appears that we cannot modify a request without getting an error in turn, invalid signature. So, starting the questions. What are its parameters here? We have a session, a signature, an encrypted ID, and a datetime. Most of the time, parameters might be self-explanatory, other times not. But from here, we can understand that the session is, of course, the session ID. The signature is what appears to be missing from us, and we cannot send a valid request. The encrypted ID must be the order ID in an encrypted form, and the datetime is just a timestamp of when the request was generated. Now, in order to find what the signature is, we're gonna use Hopper. So we start up with Hopper, and of course we want to load the binary of the application into it. And this is the part which is the most time consuming. This is where most efforts focus in order to find where to look at exactly. So let's start by finding what the signature is. And we see here an interesting function named generate signature. And what this does is takes two parameters as input and generates a SHA-256 hash. And our parameter indeed does look like a SHA-256 hash, but of what exactly? Unfortunately, using Hopper might not be that easy to identify what exactly this is, so we will use frida in order to identify exactly the input of this function. And we can use frida trace by giving it the application name, and then with the -i we instruct it to find any function that contains the generate underscore signature string. I want to see if frida finds this kind of function, and indeed it does. And as we see, when we click on an order, the function is generated. So we want to see exactly what goes in before it gets hashed. So we can actually edit the file, and since we want to see the input parameters, we will try and log the first parameter entered into the function. Using this, we will log the args1 by converting it in an Objective-C object and then into a string. If I use trace again and click on an order, we will see that this is what actually goes into the function before it is generated into a hash. And these parameters might look familiar. If you go to the latest request and see that this here is our session. And this value here is encrypted ID. This value here, as you guessed, is the daytime. And then we can see that we have another interesting value here. And if we look for it, you see that we have seen this value before, and it's the value that is returned after the login, named salt. So we have now an idea of what this is. The hash is the concatenated value of the session, the encrypted ID, the daytime, plus the hash. And if we need to verify it, we can simply copy this. Minus say 256, and this will generate a SHA-256, and guess what? It's the same. So we now know what the signature is, but we're still missing another piece of the puzzle, that of the encrypted ID. So the encrypted ID value, we'll use Hopper again and see if we can find another function. And we can see here that a function called encrypt order ID is used. So, again, in the same way, we'll try and find out what exactly this function does. As you can see here, it uses Swift RSA, so it's pretty safe to assume that it does encrypt the string. And if you remember previously, we do have something here that looks pretty much like a public key. So let's try and find the encrypted ID. Again, we can use frida, and This time we'll look for another function, encrypt order. And let's see if this triggers up. Of course, each time we click on an order, this function is called. Again, we want to see exactly the input of this function in order to better identify what it does and how it works. And we can edit this file. And if we monitor the function in Hopper, we'll see that it takes 3 arguments. So we want to log the second and the third one. If we go back, let's say click on 5, we see that we have an integer here and the public key. If we click on order 3, you can see the integer is 3 and the public key is the same. So it's pretty safe to assume that this function takes as an input the order ID and encrypts it with this public key, which was provided by the server, so the server must have the private key in order to decrypt this. So, back to the presentation. So, after the demo, we now know the what. So we know that the signature parameter is a SHA-256 hash of the session, the encrypted ID, the datetime, and the salt value. And the encrypted ID is an RSA, is an encrypted integer with a public RSA key. So we continue with the questions, and now with the how. So how can we recreate these values? The application does, and in order to fully test the backend, we need to create them as well. We can use custom scripts, for example, Python or whichever language we like. But the thing is that this might get a little bit tiring. We can generate the strings, copy them from the terminal, paste them in Burp, and go on like this. It will work, but there's definitely faster ways. Another way, we can use frida trace, and in a similar way that we traced these values, we can also replace them. Since frida allows us to use JavaScript, so we can easily write some JavaScript code and replace, for example, the integer value of 1 with something other that we prefer. But again, this is not the best time efficient solution, and we can use some more help. This time we can use the Burp plugin named Python Scripter. You can find the source code in the link below. And a short description of what Python Scripter does is it allows us to execute custom Python scripts on HTTP packets. It goes both in request and responses. So when we send an HTTP request via Burp, then this goes into the Python scripter. Our script makes any modification in the HTTP packet that we like, and then after done, it can send it to the server. Of course, this goes both ways, so we can take an HTTP response from a server, use a Python script in order to modify any value we like, and then this shows up to Burp modified. We will see exactly how Python Scripter will help us in the following demo. So, we first go, of course, to install the Python Scripter. You can find it in the Burp App Store. And once installed, we will see another tab in the script. This is where our custom Python code will go. A simple way to see how Python script works is to use a simple Python script. This is a bare, a minimum Python script, which all it does is takes the body of the request and prints it. So, by sending this request again, going into our extensions and their output, we will see that Python script there has logged our entire body. Now, of course, what we want to do is a little bit more complex. What we want each time to do is have the session, the encrypted ID, and the datetime concatenated with the salt and generate a new signature and replace that new signature with the current one. And here's an example script that will do that. Once we load the body, check that if the signature string is inside, we check the JSON parameter, we set it to empty, we use a salt, which we'll have to get each time we log in, and the message sign would be the session, the encrypted ID, the datetime, plus the salt. So all we need to do is use the current salt that our session has, and we can find this by going, of course, at the login. By pasting this in the scripter, you can see if we remove the signature, and we see that indeed we have a response back. And to make sure, what we tried before, for example, changing one simple value which returned a signature error, now does indeed come back. So this allows us now to tamper with all the parameters and have a valid signature generated each time. And now we have to see what we can do with the encrypted ID. So the process will be, again, of course, similar. We know what we have to encrypt. We know how to encrypt it. We just need to place it in a more readable way here, which can help us in our testing. So, in order to encrypt the ID, we will use a similar script. What our script will do is actually call an external script. And this is because the Python in Burp doesn't allow us to call specific functions. Our encryptor script looks like this. And since our Python does not have the crypto library, we'll have to use an external script like this using the public key and encrypt its first argument and printing that. Our Python script will run this external script, the path, the file, and provide it with the encrypted ID. And then it will get the encrypted ID and replace it in the request. We can see if this works by using the script. And we have already a blank signature, and we will try to replace the encrypted ID with the actual integer. We had order ID 3, so let's try 3 here. And as you can see, we have back the order. If we try 5, we'll take order 5. So what happens here is, with our script, we have a blank signature and an integer here. And what happens is, we call via Python scripter an external script, get the encrypted ID, replace it here, even though we cannot see it, and then go and generate a new signature for each new encrypted ID. And since Burp is doing all the hard work here, we can try one more thing and see if our life will be easier. use this request instead of 5. Why not use SQL map here? And see if it does identify an SQL injection. And as you can see in our result, SQL map did indeed find an SQL injection. Of course, you can play with other parameters of SQL map, but since Burp is doing all the hard work, we can easily use other tools and make our life even more easier. So, this was the presentation. Thank you so much for your attention and for viewing this. I'm sure that it might have seemed a little bit fast, but thankfully this is a video, so you can probably go back and forth and look at the points you want to revisit. Of course, if you have any questions, please address them and I'll be happy to answer them. Once again, thank you for your time, and everyone take care.